Hey everybody, and welcome back to Lesson 9 in the Real Numbers course. We've been talking a lot about fractions lately, and we've got quite a bit of information under our belts. For example, we know that fractions are numbers. We know how to represent them using fraction bars. We know that 4/4 is really just 1, and 0/4 is equal to 0. We know that if you take 2/9 of a bar, you're going to have 7/9 left. We talked about complements. We also are pretty good now at comparing fractions to 1/2. 9/20 is less than a half because when you're talking 20ths, 10/20 is 1/2. So 9/20 is less than a half. And 7/12 is greater than a half. And lastly, if someone asked me, hey, what's bigger, 2/9 or 3/4? I could just imagine those fraction bars in my brain. 2/9 is tiny, 3/4, it's a lot. 3/4 is bigger. And I bet you can do the same. Today, we're going to talk about something that makes fractions really special in the world of the real numbers. Before we do, though, in order to afford the astronomical salaries of our directors and our ministers of humor at all the sites, we've had to sell ad space in our lessons. I apologize for the interruption, but now this word from our sponsor. Okay, today's lesson is going to explore something that makes fractions really special in the world of the real numbers. Fractions can look very different depending on the situation. They love, if you want to think of it this way, they love to have different outfits so they can look different. Okay, not unlike people, right? You dress up in a certain way for one thing and dress a different way for another event. Okay, fractions do the same thing, and they love it. They love it. We've actually seen this before with 1/2. Okay, we just saw it before the break. For example, 4/8 equals 1/2. So even though those two fractions look different, they're really the same number, and we can think of it as 1/2 dressed up in this different outfit. It's 8ths outfit, so 4/8. But we know that 1/2 can have lots of looks, right? 1/2 is also equal to 5/10. So there's 1/2 in its 10ths outfit. 10/20, 50%. We've got infinite numbers of outfits that 1/2 can be wearing and look very different, but still be 1/2. Okay? Well, let's see if we can make sense of this. And we'll do it using our fraction bars. So 4/8 is 1/2. If I were to represent 4/8, you guys are pros at this point, 8 equal pieces, there they are, and we're going to keep 4 of them, right? Shade in 4. But if we blur some of the lines a little bit on the inside of that fraction bar, look at what we have. We're really just looking at half, aren't we? That's half a bar. So clearly 4/8 is the same as 1/2. As for another example, consider 10/15. If we do the bar, now this is normally something we would benchmark, but I've got the computer, so I'm going to break it up into 15 equal pieces. I'm going to shade 10 of them, right? And now let me do the same thing that I did in the previous example. I'm going to take away some of the bars strategically, not some of the bars, but some of the division lines there. There are a lot of them. So I'm gonna go halfway here first. See those dotted lines? Those are the ones that I pulled out. Who are we looking at? Can you see that now? Look at that bar. What's another? Good. 2/3. And if I pull those all the way out, look at that. Clear as day, 2/3. 10/15 is 2/3. We say that 10/15 and 2/3 are equivalent fractions equivalent fractions. And that's just a fancy way of saying they are equal, but just look different. That's all. All right? Now, when it comes to equivalent fractions, you sort of wonder, well, how's this working? What's this all about? We can't always draw the bars. I mean, they're beautiful representations of this, and it's clear as day. But we really want to look at the mathematics, the computational part of this that'll let us see this a little quicker than drawing all those bars. So it turns out that equivalent fractions are really all about the number 1. The number 1 is going to play a huge role in equivalent fractions. Let's take a look. We said 4/8 was equal to 1/2. Let's see how we can justify that with our arithmetic here. 4/8. What we're going to do is we're going to factor. It's been a while, all the way back in lesson 2 if memory serves, but I'm going to factor the top and factor the bottom. So 4 I'm going to factor as 4 times 1 and 8 as 4 times 2. Looking at that fraction with the factored top and the factored bottom, let me split it up for you. Let me split those two fractions, 4/4 times 1/2. Take a look. You recognize who we're looking at there with 4/4? Yeah, of course. Good. That's just the number 1. So that's really 1 times 1/2. But guys, that 1 is doing nothing. It's not changing the value at all, right? I mean, 1 times any number is just that number. So that 1 in some sense is really unnecessary. We don't need it. Like, nobody walks into McDonald's and says, hey, can you give me 1 times 3 hamburgers? Right? You get a funny look. They just say, you mean 3? Yeah, just 3. Same thing here. 1 times 1/2, there's no reason to have that 1 there. So it's just 1/2. And look at this beautiful string of equations, all the way from 4 equal signs, from 4/8 all the way to 1/2. They're exactly equal to one another, but 4/8 just has that unnecessary 1 in there. Okay? That's how it changes looks with that 1. For example, same way, 10/15. Let's do the same thing. Let's factor the top and factor the bottom. So 10 is 5 times 2 and 15 is 5 times 3. Let's separate them off again. There's the 5/5. You see in the 1? Good. There it is. 5/5 is the 1. And 1 times 2/3, that 1 is totally unnecessary. So let's not even bother with it. 2/3. 10/15 is equal to 2/3. That's exactly what we saw with the bars earlier. Okay? Now, it turns out this process works for all fractions, all right? We now have a way to simplify any fraction we want. Simplify just means make it simpler looking. So instead of 4/8, we just write it as 1/2. And it turns out that to simplify a fraction, you factor out a 1. That's it. To simplify a fraction, you factor out 1. All right, let's do some examples, all right? This is a huge fact. I hope you can get that down in your notes. To simplify a fraction, you factor out a 1. All right, how about this? 21/28. We're being asked to simplify that fraction. Well, what that means to us now is we need to factor out a 1. So what do you guys, can you give me a factorization, a way to factor 21? Just yell it out. Yeah, come on, scream it out. Nice. Who is that over there? Yeah, you. Is that a new shirt? Sweet. 7 times 3. Nice. So 21/28. The top is 7 times 3. And the bottom, let's try to use one of the factors we had in the top. How about 7 there? Yeah, good. That's 7 times 4, isn't it? Let's split them up so we can see that 1. There it is, right there. 7/7. That's just the number 1, isn't it? And 1 times 3/4? 3/4. There it is. So we've got 3/4 as a simplified version of 21/28. They're the same number. They just look different. That's the beauty of simplifying. All right, cool. All right, how about the next one? Let's do another one. What about 2/10? Let's simplify 2/10. All right, well, we need to factor the top and factor the bottom, right? It's all about factoring the number 1, factoring out the number 1. So 2/10. All right, well, I don't see many ways to factor 2 because 2 is prime, right? The only even prime. So 2 times 1. Yeah, and then 10, well, using that 2 from above, 2 times 5, huh? How's that looking? All right, let me break this up so we can see that 1. Hopefully this is looking good. You guys see the 1? Of course you do. There it is. 1 times 1/5 is just 1/5. So there's our answer. We have simplified, just made it look simpler, 2/10 to 1/5. Okay, they are the same number, they just look different. So think of 1/5 as like the naked guy, and he puts on his tenths clothes. All right, so 2/10, thank goodness he had some clothes on. We just kind of, all right, that's a bad metaphor. Never mind, let's not talk about nude fractions. All right, you guys okay? Let's do this one. The directions are a little bit different. Notice simplify completely. Hang on to that for a moment. Let's just do what we were doing before, and then we'll see what these directions mean. We know how to do this. We're going to take 12/18, and we're going to factor the top and factor the bottom. Well, tell you what, both of these are even numbers, so we can definitely factor out 2 from the top and bottom. So the top is 2 times 6, and the bottom is 2 times 9. All right, let me split up those 2 fractions like we did before. Here's our 1, right? 2/2 is just 1. 2 halves is 1. 1 times 6/9 is 6/9. So we have simplified. 6/9 is a simplified version of 12/18. But we can simplify some more. It's not completely simplified. To use my metaphor from before, it's not completely naked just yet. We just took off the 18ths outfit, and we still have our 9ths outfit on, but I think we're not down to the bare naked fraction. All right, well, 6/9, let's see, is there something we can pull out, factor out of the top and the bottom there? Yeah, good. I heard a 3, yelled out loudly, I might add. 3 times 2 and 3 times 3. Well, there's 3/3 times 2/3 if we break up the fractions again, and there's another 1. So 1 times 2/3 is 2/3. Look at that. And now we know that there aren't any more factors, common factors between the numerator and the denominator, because both 2 and 3 are prime. But yeah, they don't share any common factors. So we have completely simplified this fraction. All right, that would be our final answer. So just make sure when they ask to be simplifying completely, that you go all the way down where there aren't any more common factors. Okay, did you guys notice something? I wonder if anybody was seeing this originally. 12/18, we factored out a 2/2 and then a 3/3. So it took 2 steps to completely simplify. We might have done this a little faster if we noticed that 6 is a factor of both 12 and 18, right? So 12 is 6 times 2 and 18 is 6 times 3. If I break up the 2 fractions like this, multiply, look at that 1. 6/6 is really 1, and 1 times 2/3 is 2/3. So we get to the final answer a little quicker. You don't have to feel bad if you didn't see that. I just wanted to point it out that sometimes if you, the bigger the factor you take out from the top and bottom, the quicker you'll get to completely simplified. Okay? Guys, excellent work today. I want to let you get to work on these, and I can't wait to see how good you get at this. And I'll see you in our next lesson. Take care, guys.